The Earth's equator are the tropics. Dense, hot, rain-drenched. More than half the world's plant and animal species live in swamps and jungles. It's a vertical landscape that pushes the very limits of animal engineering. And when animals so brilliantly equipped come into contact, some of nature's most remarkable moments unfold. Snakes take flight. Tongues shoot with blinding speed. Feet walk on water. Crocs turn into toothy torpedoes. And finally, the ultimate moment, a tiger's unsurpassed strength and power. These are moments of wonder. Incredible, ingenious, and entirely real. Often they're too fast, too small, or too hidden to be understood. But if we can capture them, what it takes to survive in the jungle can finally be revealed. In the tropical rainforests of Central America, blue morpho butterflies often stay hidden in the shadows of the dark understory. Occasionally, they'll venture into sunny clearings to forage on food dropped from the canopy above. But in the jungle, danger lies in wait. A hungry lizard has caught sight of the morpho's shiny wings. And the basilisk lizard is uniquely equipped with the most wondrous means for capturing its game. The lizard's water walking seems to override the very laws of physics. A moment so surprising. To understand it, we need to unpack the critical steps that get this predator to its prey. It all starts with the morpho's wing shimmer. And it's with these wings that the blue morpho tries to mount a defense. First and foremost, they can escape by flying. But they can also stage a diversion, using a flash of their iridescent wings to startle a predator. In fact, their wings aren't really blue. The flash is a light trick, overlapping scales with tiny ridges that only reflect the color blue. What's more, when the morpho emerges from its cocoon, it's covered in markings resembling eyes. Eye spots can make a butterfly appear larger. As long as the morpho is flying, the lizard is no threat. But food at the water's edge tempts the morpho. Surrounded by water, it should be safe for it to stop and eat. With the pond in the way, most lizards wouldn't stand a chance. But this is no ordinary lizard. For years, cinematographers tried to capture its steps with varying success. Witnessed at normal speeds, their fleet-footed water dance leaves nothing but questions in its wake. But slowing the action lets us see why this animal's become so famous as the Jesus lizard. It starts with the unique biomechanics within the lizard's legs and feet. Every time it slaps its wide webbed foot on the water, it turns something that's fluid into firm footing. When their foot plunges down, it creates a pocket of air and force for support that keeps the lizard from sinking. And there's another trick at work here, the sideways force. Each lizard leg is pushing slightly outward. So, like riding a bike, each tilt to one side is corrected and counterbalanced. Of course, if you stop pedaling, you'll fall over. If the lizard stops running, it will sink into the water and have to swim the rest of the way. At the moment of the basilisk's approach, a final flashing of the morpho's wings. But it's not enough. The lizard gets its meal. Just one small act of survival, but a hint of the internal engineering that allows species to tackle an environment and thrive. Whereas much of the action on the shadowy forest floor goes unseen, up in the trees, the jungle's miraculous movement is a thing to behold. 50% of the world's animal species live up here, and it's led to some remarkable motion specialists. Ones for whom our rules for getting from here to there just don't apply. The long-limbed spider monkey is perfectly suited for a life in the trees. At 150 feet up, this is a risky high-wire act, requiring a body that's been customized, turning a monkey into an Olympian. In the rainforests of the New World, spider monkeys are a force to be reckoned with. They turn a network of branches and vines into a jungle highway. It's called brachiating. Agile primates like the spider monkey are capable of moving arm over arm through the jungle, even hurling themselves over 30 feet between trees. What's normally a blur is in fact a whole series of moments. Moments we can now see. Each a calibration of strength and timing between body and branch. The arms and legs of monkeys are scaled differently than ours. Forelimbs and hind limbs are equally long. A dexterous tail works like a fifth hand. It's even tipped with fingerprint-like grooves. Shoulder joints are rounded to allow maximum rotation. Freewheeling wrists and hook-like hands give them an acrobatic advantage for swinging. All this internal hardware paves the way for a very high-performance ride. Like most primates, they've reduced their powers to detect smell to increase stereoscopic vision, essential for navigating the branchscape and finding their way to scattered sources of food. Spider monkeys are known to cover more than a mile in a day foraging for fruit. Their astonishing powers of locomotion help them deal with the challenges of this high-rise habitat. Not every creature living in the canopy has taken up the Tarzan act. But even if they don't climb or leap or even walk very fast, they've got some surprising ways to obtain life's essentials. The forests of tropical Madagascar are home to about half the world's chameleon species, including the vibrantly colored panther. With almost everything it does, this chameleon is the personification of slow. Their tongue-like feet, working like pincers, and grasping prehensile tails keep them steady as they amble through the trees. They're in no hurry because nature has armed them in a different way to compete for canopy insects. And when one of them gets in range, Mr. Slow turns out to have an astonishing moment of speed. And its fast, telescoping tongue is matched by a quick, color-changing skin. Contrary to popular belief, chameleons don't change colors to camouflage their presence against the surroundings. It has more to do with communication between very solitary creatures. A rare moment of contact and a flash of emotion. Coloring reflects their mood when sparring with other males. Or when they're attracting the attention of females, adorned in a blander exterior. The mechanics of this color change take place just below their transparent outer skin. Stretchable pigment cells, called chromatophores, are ringed with muscle fibers. When the fibers contract, they pull on the pigment cells, quickly spreading their color. The upper layer handles red and yellow tints. Below, another layer of cells reflects blue light. While the chameleon's skin show is impressive, it's their tongue's capacity to snatch a meal from a distance that really defines the moment. The unusual attack begins with the chameleon's eyes, the most distinctive of any reptile. Each eye can rotate and focus separately. With but a pinhole in the center, they have a full 360-degree view to find prey. The slow-moving chameleon never chases the quarry, only edges towards it. He moves his head, bit by bit. Now, the eyes are locked in sync to judge the distance. Then, the tongue takes over. About 20 milliseconds. That's all it takes. But with high-speed cameras, we can observe the action as it catapults over 1,600 feet per second. How it works is another case of animal ingenuity. The tongue is sheathed on the tip of a bone that helps support it. A tightly coiled spring of collagen and accelerator muscles create a biological catapult that propels the tongue tip as a bow shoots an arrow. When extended, the retractable tongue is longer than the chameleon's entire body. Over millions of years, nature has been perfecting this design. Now we're getting a view of just how amazing it is. The sticky tip gloms on like a baseball glove. Skin flaps ensure the prey stays put as it jets back to the panther's hungry mouth. The forest canopy is almost a self-contained world. Most of its residents can find the food, shelter, and mates they need without ever having to leave. But for others, the trees are a vantage point, home base for mounting an aerial assault into an entirely different realm. A flash of feathers, plunging 80 miles an hour. Then the dive. The osprey. Nature combined an aerialist and an aquanaut with a body that moves seamlessly between two earthly domains, air and water. This powerful predatory bird was born to fish. It's spring in Florida's lake country. Hatchlings are still nest-bound, but growing fast. They're hungry, requiring as many as 7 fish a day. As the day begins, the air is soon filled with the cries of nest-bound females, encouraging male osprey to fish. It's a task for which this imposing predator, one of the largest and most powerful raptors, is well suited. 6-foot wingspan, binocular eyesight, several times more acute than humans. Sharp talons, half as long as a grizzly's claws. Once an osprey spots something swimming in the water, its most exquisite act begins. Sometimes they fish along the surface, and it's all over in seconds, like some sudden smash and grab. But osprey are best known for their watery plunge. As it catches sight of a fish, there's a momentary hover. Their focus can adjust for the refraction effects of the water. The dive is nearly vertical. Just before hitting the water, its legs are thrown forward, thrusting talon-tipped feet through the water. With a diet that's 99% fish, they've become well suited to getting wet. Their wings are the most waterproof of any raptor. Even more extraordinary is how they manage to helicopter back up into the air. Key to this feat are the large flight muscles centered in the chest and their characteristic V-shaped wings bent at the wrist joint. Even without a run-up or a perch, they can generate airflow across their wings to create lift. Spearing and holding on to a wriggling fish isn't easy. These birds are equipped for this as well. An osprey's feet are scaly for extra gripping power, and unlike other birds of prey, the outer toe is reversible, so they can grab with 2 toes forward and 2 toes back. Once the fish is firmly held under wing, the osprey heads to the nest. The biomechanics of flight are 100 million years in the making. It's generated an extraordinary range of wing design. Some are so broad, there's little need for flapping. All the energy is tapped from air currents to sustain the glide. At the other extreme are the most frenetic wings in the animal kingdom. The hummingbird generates 50 wing beats a second, so fast and so precise they can hover in mid-air. Perfect for extracting a meal of high-calorie nectar. As our cameras have improved, we're finally getting to see what it means to fly. Ingenious body design, split-second timing, and a little luck, it all adds up to a moment of impact. But perhaps the most fantastic feats by jungle athletes are achieved by some of its smallest. They're performed daily, but often out of view on the forest floor. In the jungles of Venezuela, the noise of the canopy above is but a distant racket. The forest floor is quiet. Yet despite the apparent calm, it's a torrent of activity. The largest group of animals living in the jungle is busy. Insects, the variety of their forms is staggering. Their capabilities, astonishing. These leafcutter ants are showing off their super strength, transporting plant material 10 times their own weight, equivalent to humans carrying around Volkswagens. It's always rush hour here, a relentless headlong push to bring plant fragments to their underground fungus gardens. All this heavy lifting, carried out by a totally female work core, comes down to a pair of powerful muscles in the jaw. And just below the leafcutters is another ant with superpowers, the carnivorous trap-jaw ant. They make their homes in leaf litter and logs. Unlike the leafcutters, these ants can't dig. Their oversized jaws make that impossible. But these massive mandibles open up other possibilities. For the longest time, the true force of their bite went unnoticed, until scientists realized that within this tiny ant's jaw is a bite force stronger than a shark's, accelerating at 2,300 times faster than the blink of an eye. Missed it? Here it is again, filmed at 1,000 frames a second. A creature this small isn't supposed to generate this kind of force, 300 times its own body weight. But it's an example of nature designing a crossbow to amplify muscle power. Huge contracting muscles in the head are held with a biomechanical latch, spring-loaded and ready for a trigger, usually when sensory hairs on the insides of the jaw are stimulated. The force of the jaw strike is so strong, if it strikes against the hard ground, the recoil can catapult the ant into the air. In human terms, it would be a leap of 130 feet. Scientists aren't certain how the jaws of these ants got pushed to such extremes. But unlike many other ants that work in groups, trap jaws are solitary hunters. Since they're on their own, perhaps each attack has to count decisively. whether it's defending the colony or transporting food. For many jungle ants, the business end of this endeavor is the jaws. And from an ant jaw measured in millimeters, we go to a set of choppers that's one of the largest. Among crocodiles, nature has created one with a volatile mix of gymnastic ability and aggression. The real secret is how they shoot from the water, getting those jaws delivered exactly where they need to go. It's thought that there may be as many as 6,000 crocodiles living on the subtropical Isle of Youth off the coast of Cuba. Difficult country for humans to maneuver, but ideal for Crocodylus rhombifer, the Cuban croc. Since it is spring and breeding season, the crocs are more visible and aggressive. Backing up that aggression is some bioengineering fit for a beast. Up to 15 feet in length and 300 pounds. Its scaly skin is heavily armored. A thrashing, muscular tail. Strong legs and reduced foot webbing make it as agile on land as it is in the water. And under the hood, 66 bone-crushing teeth packed into a jaw built for chomping. For 200 million years, crocodilians around the world have evolved tough, muscular bodies, ascending to the top of the pecking order as apex carnivores. Mess with almost any crocodile, pay a heavy price. Just how able-bodied, swift, and powerful they can be is surprising. For the unsuspecting, their moves are out of the blue, reaching speeds of 25 miles per hour, faster than a charging horse. But the Cuban croc takes its body's skill set to an entirely different level. This croc's attack isn't limited to the water or the shoreline. As it moves through the water, its eyes are focused on the trees above. The rhombifer has a keen sense of smell, and right now, it's picking up the scent of hutia. In Cuba, there's a tree-dwelling rat that grows as big as a house cat. But taking refuge in a tree doesn't ensure the hutia is safe. Not when a Cuban croc is close and equipped with a body engineered to jump. The croc's tail accounts for 30% of its body mass. It begins to thrash. When the strike occurs, it has all the muscle and form of an Olympic dive. Rocketing straight out of the water to heights of 6 feet, a croc can snatch animals from trees. If they can get a push off with their feet, they use it. But the real power behind the leap is bioengineering in the tail. The tail vertebrae are connected by ball and socket joints, permitting maximum range of movement. A system of muscles running from the skull to the tip of the tail creates a single drive chain capable of tremendous coordinated power. It all works to turn this croc into a toothy torpedo. In the swamps where they live, the supply of fish is unreliable. Perhaps the Cuban croc's propensity for leaping and their adaptations for moving with agility on land allowed them to expand the menu. Some of nature's most arresting moments are caught up with the hunt. Locate, launch, capture. But for most animals further down the food chain, the name of the game is defense. A whole host of behaviors and body design has developed to try to stay alive. For all their prowess as hunters, jungle snakes have enemies too. So some of their weaponry is defensive, designed to ward off an attack before it's too late. But sometimes the best way to fight is flight. One snake has become a consummate escape artist. The paradise tree snake lives in Southeast Asian rainforests. Among their adversaries is the sharp-clawed yellow monitor lizard, an accomplished snake hunter. While the tree snake can miraculously scale even vertical tree trunks, it would be hard-pressed to compete with the monitor's climbing agility. What's more, the canopy isn't continuous. Wide gaps between the trees prevent an easy getaway. But paradise snakes have found a better way. When face to face at the moment of danger, tree snakes make use of a truly remarkable defensive weapon, worthy of James Bond's ejector seat. The moment of danger has turned into a moment of flight. To really understand this pilot's technique, it's best to start at the launch. Tree snakes will move down a branch end and beyond, falling into a J-shaped bend, leaning into the incline as if determining a destination. But once it's in the air, how does an animal with an inner tube for a body transform itself aerodynamically? After launching, it sucks in its guts and flares its ribs to make a U-shaped wing. Increasing its size adds to air resistance. But are these snakes doing anything more than falling with style? In super slow motion, their flight is even more spectacular than thought. The body flattens down to but a ribbon. And they appear to be assuming a degree of control, undulating as if swimming, holding the tail upwards and twisting from side to side for balance. Literally, snaking through the air may help it achieve some steering and sail distances of 300 feet. It may have to endure a hard landing, but at least its pursuer has been left on the other side of the canopy. Sometimes the best defense is the opposite of escape. Staging an elaborate charade in plain sight is a way of avoiding the moment of impact. Nature has given the red-eyed tree frog a number of techniques to protect itself. First, it's vibrantly colored to fool predators into thinking it's a poisonous frog. It's not highly toxic, only mimicking the markings of dangerous species like the poison dart frog. Predators that have learned to avoid the lethal frogs will also bypass an imposter. Still, this may not deter a hungry snake. If it is in danger, the tree frog changes strategy. By opening its bright red eyes and showing its bright blue sides, it can confuse an adversary for a split second, just long enough for the frog to try to flee. And for a final trick, a cloak of invisibility. With closed eyes and folded legs, a tree frog is comfortably concealed in plain sight on a tropical leaf. While jungle animals use visual displays and camouflage to get by during daytime hours, when the night shift takes over, it's a whole different story. In the dark, sound is the means by which hunter and hunted compete. And one creature in Central American rainforests takes sound to an entirely new level. Bats are the only mammals with wings and the capacity for true flight. Combine that with an onboard sonar system, and the result, a moment of aerial impact. It may seem bizarre, but eating and sleeping upside down works perfectly for bats. Once their feet are locked, they don't need muscle power to hold on to the roost. At the onset of dusk, a frog-eating bat's long horn-like ears are poised and listening. But how do they detect, locate, and capture a target lying low in a terrain full of branches and vines? Bats send out pulses of sound waves to echo against the terrain. A muscle in the middle ear is synchronized to contract the eardrum during each brief pulse so it only hears the echo. As the sound travels outward, it impacts objects and bounces back, helping the bat avoid collisions and locate prey. The sound of frogs fills the night. To attract a female, the Mexican white-lipped frog makes a series of chirping sounds. It's risky behavior. In competition with other male frogs, the vocalizations increase, making the frogs more conspicuous, not only to females, but to predators too. The fringed-lipped bat has evolved its hearing to specifically tune into the calls of the white-lipped frogs. It's locking onto an auditory target. And when bats want to fly, they drop free from the roost using gravity to assist them. As it hunts, its broad but flexible wings work like human arms and hands, almost swimming through the air. The wing membrane is actually skin extending from the body. It's thin, but tough and flexible, and if torn, heals fast. When bats are foraging, frogs try to stay hidden or reduce their calls to a brief low-frequency rumble. But once it's detected a target, this graceful flyer can swoop low and even hover while its sharp teeth spear the prey. After capturing a meal this big, a bat returns to a roost to consume it at its own pace. $86,400. That's how many seconds there are ticking away each day. Most pass unexceptionally. But every now and then, there's a moment. Often the split second between life and death, when creatures are tested to their very core. Nature is always finding new ways of adapting the equipment, and we're beginning to be able to keep up with it, going inside the moment with these creatures to finally see how it all works. The variety of